its current scenario, prevention and control. We know that foot rot is economically important disease of ruminants, particularly sheep and goats, because it affects the sheep and goats a lot. Other ruminants are also affected, like cattle, pigs, deers, meflon. It is economically important in the sense that it puts heavy burden on the sheep and goat rearers. Like it affects the meat production, it affects the quality of the wool and the quantity of the wool. The body, there is loss of the body weight. The animal loses weight, and said these are the direct economic impact, and indirectly there is the farmer has to buy the veterinary medicines, and he has to spend a lot of money on the treatment. So in that sense, it is economically important disease. Disease is worldwide. The distribution of disease worldwide, like Australia, New Zealand, United Kingdom, USA, all these countries have reported these diseases. Particularly, this disease attains epidemic proportions during the rainy seasons. Particularly when there is a rainy season, the disease attains epidemic proportions. Now, coming to the symptoms, this is the sheep. I have taken this photograph in the field. You can see the sheep is grazing at its knees. So the symptoms includes there is interdigital dermatitis. Initially, there is a swelling, redness in the interdigital region, and there is a sloughing of the hoof. The sheep is there is severe lameness. There is loss of body condition. It affects the wool. The wool quality and the quantity is affected. Since the immune system is depressed, the animal is susceptible to life-threatening condition. So coming to this, this disease, as I said, I have also taken this photograph from the field. You can see here the necrosis of the hoof, necrosis of the hoof, and there is detachment of the hoof from the underlying soft tissue. As I said, this disease begins as the interdigital dermatitis. It affects the interdigital skin, and it moves to the skin horn junction, and ultimately there is separation of the hoof from the underlying soft tissue. You can see here, this is the scoring system given by the Stewart and Claxton. You can see here that this is the healthy foot. This is the region where this foot rot is affected. This is the interdigital skin where the disease, this bacteria, it targets. Then this is the skin horn junction. This is skin horn junction where this disease progresses. Coming to the score 1, you can see here clearly that this is the interdigital skin. There is a redness, there is inflammation, there is loss of hair, and this is considered as a score 1. Coming to the score 2, you can see here that there is necrotizing inflammation. You can see this is skin horn junction is affected. There is this whitish area. This is a necrosis. There is loss of hair. There is inflammation. Okay. Now coming to the another, that is score 3. You can see there is underrunning. There is necrotizing inflammation and underrunning. There is separation of the hoof from the underlying soft tissue. Now coming to the score 4, you can see that this underrunning, it is extends to the outer side of the wall, and ultimately in the severe cases when the lesion score is 5, there is total separation of the hoof from the underlying soft tissue. The deeper tissues like lamina, they are affected. So coming to its etiology, as we all know that etiology is complex, but the main transmitting agent is Dichelobacter nodosus, the main transmitting agent that causes the disease. This another bacterium is Fusobacterium necrophorum that does not cause foot rot, but it contributes to the severity and the duration of the disease. Main transmitting agent is nodosus, but it is if the Fusobacterium necrophorum is present in the lesion, it increases the severity and the duration. And another bacteria, that is Trupella pyogenes. Earlier, it was called Archaeobacter pyogenes. It also helped in the survival of this Fusobacterium necrophorum. It provides certain factors that improves the growth of Fusobacterium necrophorum, and we know that the Fusobacterium necrophorum, along with D. nodosus, they cause the severe foot rot. And another organism, that is Treponema. Here you can see Treponemes. They are mostly responsible. They are also found in the foot lesions. They are also found in the foot, but they do not cause foot rot. They mostly cause a disease that is called as contagious ovine digital dermatitis. In cattle, they cause bovine digital dermatitis, and in cattle, they cause contagious ovine digital dermatitis. This is the first disease. This is a new. It was first reported in 1997 in England, and we have recently reported this in India, in Kashmir. So this is all about it. Another organisms like Staphylococcus aureus, Macrococcus, Micrococcus, Corynebacterium, they are also found. But the main disease that foot rot is caused by the Diazotobacter nodosus. The main transmitting or the essential transmitting agent. Coming to, we'll be focusing on the Diazotobacter nodosus. We know that this is the strict anaerobic bacteria, means that if it is exposed to the oxygen, the bacteria will be killed. So it is gram negative, and you will see that this bacterium is surrounded by the fimbriae. And these fimbriae are type 4 fimbriae, and this type 4 fimbriae imparts twitching mortality to the bacterium. This is very slow growing bacterium. It is a fastidious in the sense that it is a strict nutritional requirements. It requires a lot of nutrients grow in the laboratory, and it is very difficult to grow in the laboratory and difficult to isolate, as we already discussed it. So this disease is extremely contagious, and this has 10 serogroups. This disease, on the basis of this fimbrial antigen, this has 10 serogroups, and these serogroups, they don't give cross protection. And the disease is recurrent. Recurrent means that once the disease occurs, and if you treat the animal and the animal recovers, then again all the conditions are again met, the disease will recur. And it has a wide host range. As I said, it not only affects the sheep and goat, it affects other ruminants as well. Coming to the predisposing factors, they include temperate climate. Initially, it was thought that the temperate climate in the disease is prevalent in only in those areas where the climate is temperate. It's a cold climate. But it has also been reported in other tropical, those countries that are tropical or areas that are tropical. Like if we say that in India, it has been reported in Andhra Pradesh, it has been reported in Rajasthan, other tropical areas. Predisposing factors include the muddy pastures. When there is a rain, when there is water logging, and there are muddy pastures are around, the disease flare up. It attains the epidemic proportions. And the other predisposing factors, they are these. When these, we know that we have this migratory flock. They in April they move to highland pastures, and they have to move through these rocky, hard surfaces that causes injury to the feet. Other things, these thorns, wires, sharp objects, they injure the hoof, and these are all the predisposing factors. And when they at highland pastures, when the sheep from the different areas they intermingle, it causes it spreads the disease. It transmits the disease to other flocks as well. So they are all the predisposing factors. Coming to the bacterium, we know that you can see here the electron micrograph of the bacterium. This is the bacterium, and you can see clearly here that these are the fimbriae. And as I earlier said, that this fimbriae, on the basis of these fimbriae, there's a variation in the fimbriae, and on the basis of this variation in the fimbrial antigen, this nodosus has been classified into 10 serogroups. The A, B, C, D, E, F, G, H, I, and M. There are 10 serogroups of this on the basis of variation in these fimbrial antigens, and they are further subdivided into 21 serotypes. Means A serogroup is divided into 2 serotypes, C, E, F, G, H. They are divided into 2 serotypes, while as B is divided into 6 serotypes on the basis of variation in the fimbrial antigen. And this serogroup, earlier after 2013, there were only 4 serotypes in serogroup B. But now our laboratory has added 2 more serogroups to this, 2 more serotypes to this serogroup, like B5 and B6. And this B5 is the predominant serotype in the J&K. Coming to the distribution, distribution is worldwide, and serogroup distribution of serogroup varies from country to country. Say in India, serogroup B may be predominant, while as in New Zealand, serogroup A, in Nepal, serogroup M may be predominant. So serogroup, there is variation. Distribution of serogroup varies from country to country, and as I earlier said, that there is no cross protection among the serogroups. You don't give, if, for example, the animal is affected with serogroup B, and you are administering vaccine that contains serogroup A. Animal, it will not cure, it will not protect the animal. So there is no cross protection among the serogroups. Coming to its clinical forms, there are actually 3 clinical forms: virulent, intermediate, and benign. Here we'll be discussing 2 which are important. For example, I will tell you that if the bacteria is there are virulent strain, the disease outcome will depend upon the strain of the bacteria that is infecting. If the strain is virulent, the host is susceptible, and the environment is conducive, outcome of the disease will be very severe. It will be very severe. Here, the strains, they are differentiated into virulent strains or benign strains, and we need to differentiate the strain, because it is virulent, it is very severe. It causes severe foot rot. It causes the lesion score progresses from 2, 3, and it reaches to 5. So this is the target. But while this benign form, it is a self-limiting, self-curing. So if it is affected, the animal is affected with the benign strains, the disease will self-cure. It is self-limit. So it is not the target. Our target should be is virulent. So how to differentiate these? So for example, the animal is infected with a bacteria. How will know whether it is a virulent or whether it is virulent or it is benign? So if the lesion score is high, it is clear that the animal is infected with the virulent strains of the serogroup, this genodosis. But if there is this lesion score is say 2 or 3, 2. So we cannot say that whether it will progress into the it will progress into the severe foot rot or it will be self-limiting. In order to differentiate that, there are certain tests that will differentiate between the virulent or the benign strain. The first test is last stage test. This test measures the enzyme activity. Basically, these virulent strains of denodosus, they produce elastase that digest they produce enzyme elastase that digests the elastin. Basically, we have an elastin agar. So trypticase adenosine agar that contains elastin. And if we just inoculate the denodosus culture on the elastin agar, so it will clear the elastin within 7 days. While as these benign strains, they will not clear it even after 21 days. So by this, we can differentiate between the virulent strains or benign strains, because virulent strains will digest this, clear the elastin within 7 days. Now, coming to the another test, that is gelatin gel test. This gelatin gel test measures the proteases, thermostability of the proteases, and it has been reported that virulent strains of denodosus, they produce thermostable proteases. That is, if these they produce thermostable proteases, say we can have this, we can have this gelatin gel. We prepare this gelatin gel, and what we do in this gelatin gel test, we prepare the broth culture. We inoculate the bacteria in the broth and grow the bacteria in the broth. And after growing them in the broth for 48 to 72 hours, then we heat the broth culture for 8 minutes. Say 8 minutes, and then put that heated broth culture into the, say we have a gelatin gel test or slab. We just punch the valves here. Then we inoculate. We put this broth culture to 20 microliters of broth culture and heat it. And after heating heating it at 67 degrees centigrade for say 8 minutes, and then for 16 minutes, and then we see the clearance of the gelatin. You can see clearly those virulent strains, they clear the gelatin, they digest the gelatin even after heating it for 16 minutes. So they are the virulent strains. And this elastase test and gelatin test, they are correlated. Those strains that digest, that clear the elastin within 7 days, they also produce thermostable proteases. But I guess the disadvantage with these two tests is that you have, it is cumbersome, it is time consuming, and you have to first isolate the organism, which is very difficult. All the laboratories, they don't have expertise to isolate this organism. So another test these two tests, they are phenotypic tests. Another test is the genotypic, that is PCR based. All the laboratories can do that. Here we target the gene, that is APRV2 gene. That is, A stands for acidic, PR stands for protease, and V for virulent. So virulent strains of denodosus contains this gene. They have this gene. If this gene is present in the, simply you have to get the swab, you have to extract the DNA and put the PCR. Simple. And if the gene is present, APRV2 gene is present, it means that the strain that is infecting the animal is virulent. And then lastly, the clinical picture. We know that this clinical picture, if the sheep is having the lesion score of 4, it means that the strain that is infecting the sheep is virulent. It's clear. If you come from clinical picture, you can clearly see, differentiate whether the animal is infected with the virulent strain or the benign strain. Now, coming to its economic importance, as I already said, this is economically important disease. It puts burden on the animal, this sheep and goat rearers, because the affected animal, there is loss of the body weight. It affects the quality and the quantity of the wool growth. It also, there is decreased fertility. The rams are in fact affected with this foot rot. They fail to breed. There is severe lameness. They fail to breed. So there is also recurrent treatment and control costs. All these things, they put economic burden on the farmers. And it has been reported in Australia and New South Wales that its foot rot costs around 42.6 million Australian dollars per year. And in UK, it costs around 24 million pounds per year. That's huge amount. Now, coming to the Jammu and Kashmir, we have already done a little work here on this. Cost its foot rot. It alone costs around 5,377 lakh rupees. The losses are due to the foot rot of 5,377 lakh rupees, or 537.7 million. These are due to the food rot. You can see that we have a total sheep population of J&K is around 37 lakh or 3.7 million, and we have determined its prevalence. It is around 15 to 16%. And by this, we have calculated that losses due to the food rot alone, if we consider the 10% production losses, are around 509.4 million rupees. If we consider that the live weight of animal is 300 rupees per kg, so it will come out to be 509.4 million rupees or 5,094 lakh rupees losses due to the food rot. And if you will add treatment costs, they around 50 rupees per animal, so it will come out to be 28.3 million rupees. And if we'll sum these two, it will come out to be 537.7 million rupees of losses due to the food rot in Jammu and Kashmir alone, in 20 districts of Jammu and Kashmir. And that's huge. Coming to the treatment and control, we know that treatment it is less effective because the disease is recurrent. But first treatment that we comes to mind is food bathing. If the animal is affected with the food rot, the chemical that is used in the food bath is copper sulfate or zinc sulfate. 10% copper sulfate or 10% zinc sulfate. Formally, 3% formula is also used. Copper sulfate is toxic. It is a corrosive chemical, so you have to take precaution. Similarly, zinc sulfate is less toxic. You can also you can use. You have to keep the animal in a contact time should be around 15 minutes. So if you have input solution, so this is one. If the animal is affected with food rot, secondly, the antibiotics. We have seen that antibiotics, we have just isolated organisms. The virulent strains, they are sensitive to, done this antibiotic sensitivity test. And we have seen that the antibiotics like tetracycline and androfloxacin, they should be considered first when during treatment. Even the disease is recurrent after when you treat the animal. Then the third point is that anti-inflammatory drugs. Melonex is given, then meloxicam or fliximazine, these are the anti-inflammatory drugs. They are also considered in the treatment of the animal. And the fourth is ozone therapy. The ozone therapy is new. This is not acid in India. This is acid in Europe. The main thing is they have the ozonated these oils, vegetable oils, or ozonated these olive oil, or they have the creams. You apply, or the these gases or sprays. They apply these ozonated creams or drugs there on the lesion, so it improves the oxygen delivery to the tissue. So since the tissue is there anoxic, it improves the oxygen delivery and kills the organism. This is a therapy that in Europe it is used for the treatment of foot rot. And another here is a creosote oil. It is here in India. It is available in the trade name of cow. The herb is used for the treatment of foot rot in India here. And also another important thing is food caring or trimming of. This is another important thing we should consider in the treatment. If the animal normally is a management practice, normally if the animal is not affected, you should do this food caring twice in a year at least. So if the concept, the logic behind this is that when we trim the hooves, we expose this to the oxygen, and it improves the penetration of drugs. So it also helps in the prevention of this treatment of this foot rot. Now coming to the control, we know that it's a multi-pronged strategy. This treatment management aspect is there. Pairing, which I discussed it. We have to trim the hooves, and then it will improve the penetration of the drugs, the antibiotics, and it will expose the tissue to this oxygen, and that will kill the organism. And coming to the vaccines, since this, as I already discussed it, that it has a 10 serogroups, A, B, C, D, E, F, G, and H, and they vary in their distribution. So we cannot take care of, if anybody will say that why not incorporate all the serogroups in a one vaccine? That will be effective. It will be effective in all. We can use this vaccine across the globe, but that is not the truth, because if we incorporate all the serogroups in the vaccine, that it will not give the protection. There's a protection titer. It will not achieve that protection level. So it will be a failure. So in that case, whenever you have to prepare the vaccine, you have to use either monovalent or bivalent vaccines are effective. And even for that, you have to first see which serogroup is predominant or prevalent in your area, and only you have to incorporate that serogroup or serotype into your vaccine. And that is difficult. That is the reason the vaccine is not common in India. So world is in search of a cross-protective vaccine. Now, what people, the researchers are doing, they are just trying to identify a particular antigen that is common to across all the 10 serogroups. So that antigen, if they are identifying that, if that is identified, then they will protect animals across serogroups. So there will be a common antigen that will protect all the serogroups. If that vaccine is identified and we can formulate the vaccine of that antigen, that will protect the animals, whatever serogroup is infected. This is our country, and you can see here that not only the J&K, but Himachal Pradesh is there, Uttarakhand is there, Tamil Nadu is there. Number of states they are affected. They have reported the foot rot. Now coming to this foot rot, since we know that the pioneering work, we have started this work. We have started this in our laboratory and initiated the work. And we first detected this organism in the outbreak in 2003, and subsequently in 2007, we just isolated this organism, and we have found that serogroup B is the predominant serogroup, followed by serogroup E and I. Even though we have detected A, C, F, and G serogroups as well, but most predominant serogroup is serogroup B that we have identified. And subsequently, we prepared a vaccine, whole cell serogroup specific, serogroup B specific vaccine, first time in the India. You can see here, this is the animal that is affected with foot rot. That is affected. We can see that the Regin score is 5, and we have isolated this organism. You can see this is the picture. This is the pure culture of the Dichelobacter nodosus on the Triptychus arginine agar. You can see here the ground glass type colonies on the agar. This is the gram staining of this bacterium. You can see here under 1000x magnification. You can clearly see that gram negative rods, and they're curved. You can see here these rods, they are curved and they are bulged at the ends. This is the characteristics of the Dichelobacter nodosus. Now coming to another bacterium, we have also, our laboratory has also isolated this bacterium, that is Fusobacterium necrophorum. You can see here that this agar, the media, it is plain heart infusion blood agar containing 10% sheep blood. You can see here the colonies of this Fusobacterium necrophorum, they are flat, grayish, and surrounded by a zone of beta hemolysis. You can see in microscope they appear as long rods. They are fusiform. They are long. They appear as long rods. Gram negative long rods. Now coming to the vaccine. So we are the first in India to isolate the organism in 2007, and subsequently we formulated the whole cell vaccine. This vaccine, we have given the trials in the field, and we have seen it's highly effective. This protects the highly efficient and protects the animal against the disease. And this gives the protection against for 4 to 6 months. So, and this is 4 to 6 months to animals. So you can see here clearly that the vaccine that we have prepared, it protects the animal against the foot rot for a period of 6 months. This is the protection titer. Around 3,000 is the protection titer, and from 30 days onwards, we give this vaccine subcutaneously, and the booster dose is given after 1 month. It protects the animal for up to the 6 months. You can see here the effect. This is before vaccination. This is the animal that is before taking photograph before vaccination, and after, this is the photograph after vaccination. Total complete healing. Now coming, this is the molecular test like PCR detection of serogrouping, and we can see here clearly that we have determined the prevalence in various districts of J&K, and it is around 15.14%. And here in this, you can see the distribution of the serogroups, and serogroup B is the predominant, present in more than 90% of the samples. Now coming to the prevention and control of this disease, as I said, we should always consider, whenever you are purchasing a sheep, you should always see that from where you are purchasing. If you have the flock is having the history of foot rot, you should never purchase sheep from that flock, because even if the sheep is healthy, it must be a carrier, and when you will introduce the sheep in your flock, it will create havoc, and there will be cases of foot rot may occur. The cases of foot rot might occur. Secondly, if you are purchasing sheep from the flock which is free from the foot rot, still then you should not directly introduce your sheep into your flock. You should at least separate the sheep for the period of 30 days, and you should re-examine the sheep and trim the hoofs and apply the apply these food baths, so that, and only after 1 month, if the sheep is fine, you can introduce that into your flock. And all those these vehicles in which you are transporting your sheep, your flocks, they should be clean, they should be disinfected. It's very important, because it is another aspect that transmits the disease. Thirdly, zinc is also important for the prevention. If you feed, it has been reported that if you feed zinc at the rate of 1.5 gram, 0.5 grams for the period of 21 days, it helps in the protection. It protects the animals. It protects the animals against the food rot. So this is another aspect. So antibiotics, this is all about the prevention and control. This is our publication that we have recently published in this, on food lameness, ovine lameness, and microbial pathogenesis. Thank you very much.